In this exercise, losses follow a Pareto distribution with alpha strictly larger than 1 and theta unspecified. We need to determine the mean excess loss function and calculate the limit, where d goes to infinity, of our mean excess loss function evaluated in the point u times d divided by the mean excess loss function evaluated in the point d for any u in the interval from minus infinity to plus infinity. Now the mean excess loss function of a random variable x is defined as the expected value of x minus d, conditioned on the fact that x is strictly larger than d. Now in the book we also saw that we can write this mean excess loss function in function of the survival function of a random variable, namely the mean excess loss function is equal to the integral from d to infinity of our survival function divided by our survival function evaluated in the point d. Now we know that the survival function is equal to 1 minus the cumulative distribution function, and for a Pareto distributed random variable this is equal to 1 minus theta divided by x plus theta to the power alpha, which is just equal to theta divided by x plus theta to the power alpha. Now if we fill this in, we get the following expression for our mean excess loss function. In the next step, we work out the integral. This first part is independent of x, so we can just write it down. Okay, now we need to let x go to plus infinity. You see that x is actually taken to the power minus alpha plus 1. Now since alpha is strictly larger than 1, we know that minus alpha plus 1 is strictly negative. So we get the limit where x goes to plus infinity of theta plus x to the power minus alpha plus 1, which is 0 because of the negative exponent. So in the first part we get 0. For the second part we need to evaluate x equal to d. So this results in theta plus d to the power minus alpha plus 1 divided by minus alpha plus 1. We can then simplify this expression to get the following for the mean excess loss function. Now the limit, where d goes to infinity, of our mean excess loss function evaluated in the point u times d divided by the mean excess loss function evaluated in the point d is equal to the limit where d goes to infinity of theta plus u times d divided by alpha minus 1 divided by theta plus d divided by alpha minus 1, which is simply equal to the limit where d goes to infinity of theta plus u times d divided by theta plus d. Now since theta is a constant, we know that the limit where d goes to infinity of theta plus u times d divided by theta plus d is equal to the limit where d goes to infinity of u times d divided by d, which is then simply equal to u. And this concludes the exercise.